So section 6.2 definitely continues and picks up where section 6.1 left off. If you recall, in section 6.1, I think we just basically, reviewed what the less than sign looks like, and less than or equal to, and what the greater than sign, looks like, and how. And you don't have to write this down. I'm just gonna. And we went over basically how something like this is graphed on a number line. Like how do we a very simple inequality like that with an x variable. What does that graph look like, or what does this graph look like? And we talked about when to use an open circle and when to use a solid colored in circle, and that was section 6.1. So this is section 6.2, and we're continuing with it. So here we go. What inequality symbol would go between these numbers, 6 and 8? So what symbol would it be? A less than, a greater than, a less than or equal to? What symbol? 6 is what than 8? It's less than 8, and so that's the less than symbol. And so in this activity, and that's all this is, it's just an activity, right? We're going to work with this as a starting point, and we're always going to go back to the starting point. You'll see what I mean. So we have 6 is less than 8. What if we were to add 2, and maybe if I want to be a little clearer about what this means, add 2 to both sides. Well, if we add 2 to both sides, the 6 would become an 8, and the 8 would become a 10. And the symbol what would the symbol be? It would still be a less than, right? And what if instead, subtract 2 instead from both sides? Again, we're, like I said like 30 seconds ago, we're always going to go back to the 6 is less than 8, okay? And if we were to subtract 2 from both sides, we would get 4 and 6, okay? And the symbol that would go in between would be a less than. 4 is less than 6, still. What if you instead multiply by 2? Again, always going back to the original. If you multiply both sides by 2, you get a 12 on the left side and a 16 on the right side. And 12 is less than 16. And here, what if instead we multiply by a negative 2 from both sides? Okay, so again, starting here, 6 times negative 2 is, well, negative 12, right? And 8 times negative 2 would be negative 16. And the symbol that goes in between these two numbers, negative 12, is, would it still be a less than? Is negative 12 less than negative 16? Well, especially when you think of a number line, negative 12 is not less. See, negative 16 is the one that's less because it's more negative. And so the symbol that actually goes in between these two numbers like this, with the negative 12 here and the negative 16 here, is a greater than. Negative 12 is greater than negative 16. So, that was a change. And then what if we reset and we divide by 2, positive 2? And so, again, going back to the original, 6 divided by 2 is a 3, I do believe, and 8 divided by 2 is 4. I didn't even use a calculator for that. I'm so smart. And so 3 is what then 4? 3 is, okay. Oh, that's right. Swerved ya. 3 is less than 4. That's right. I remember that was a mistake. Can't remember if that was on purpose or not. But anyway, 3 is less than 4. Okay? And what if instead we divide both sides here by -2? Well, that would obviously be -3, and over here, -4. And once again, we see that, we have to make this a greater than. What the heck am I doing? Greater than. Tricked you again. Because -3 is greater than -4. -3 is not as small as -4. Again, think of the number line. Which one's more left? It's not -3. So -3 is greater than -4. Okay, so again, this was just an activity. It's not like you're going to have homework questions like this. Definitely not going to have test questions that's just like this. This was an activity to show you something about inequalities, which sort of leads to something you're going to have to remember, and like a step you have to remember when we are actually solving more complex inequalities. We're trying to, anyway, let's cut to the chase. Which operations made us flip the symbol? Well, flipping the symbol means the less than became a greater than. So when we multiplied by -2, we had to flip it to a greater than. And also when we divided by a -2, we had to flip to a greater than. None of the other operations, adding, subtracting, multiplying by a positive, dividing, these are the only two. Okay, so, I don't know, whatever. I don't know if you want to do the same, but those two basically. So, and this is actually something that happens in general. Didn't have to be a -2, it could have been a -4. It's just the way negatives are. So the symbol only changes when you multiply or divide by a negative number. And again, this was just to show you, I don't know if it's a really, really, really great explanation why, but that's just the way inequalities are. It's just the way less than and greater than and numbers being greater than each other or less than the other one. It's just the way that works. If you multiply or divide two numbers like this by negative numbers, then you're going to have to flip. And it's not just a less than becoming a greater than. If we turn this around and it was a greater than, we'd have to flip it to a less than. So it works both ways. You flip the symbol no matter what the symbol is, less than, greater than, as long as you are multiplying or dividing by a negative number. And this is just, okay, a little repetitive here, but when you multiply or divide by a negative number, flip the sign, or as I say, the symbol. No offense to Mrs. Klut's notes. I'm not saying she's wrong or anything. So this is not saying this is wrong. It's just I like using the word symbol, and maybe that makes me wrong in a way. I don't know. But when I see the word sign, I think of like negative sign or positive sign. So I usually refer to these things as symbols. Again, I don't know. Maybe I'm wrong about that. Whatever. But yeah, bottom line. When we are solving stuff like this, and we're adding stuff to both sides, squaring both sides, dividing both sides by whatever, anything you got to do in order to get x all by itself, because that's what solving means basically. You're getting x by itself. And if you find yourself along the way multiplying or dividing both sides by something negative, you have to flip the symbol right then and there. So let's see this in action, I suppose. Stop that. Solve for x. Then graph the solution on a number line. Whoa, look at these number lines. Okay, so this one, very simple. We've done this 100 times. Looks like we have to subtract 5 from both sides to get the x alone. So 10 minus 5 is 5. And so that's the solution once x is by itself, so x is less than 5. But since that is like an infinite number of answers, and we could, I mean, it makes enough sense to have a graph accompany it. You can obviously graph these. A graph is a very good visual for this solution. And so just like in 6.1, all I have to do here with a blank number line is put a 5 right there, and that's going to be an open circle because it's just strictly less than. It's not like it's less than or equal to 5. So 5 is not technically included in the solutions. 5 is not technically included in the graph. So we're going to leave this an open circle to say, like, okay, we're not really including 5. 5 doesn't really count. But everything less than 5, which is obviously everything to the left of 5, we're graphing that big time. So that's number 1. We did not have, okay, final comment, since, I might as well point this out. We did not have to flip the symbol. It stayed less than because you only flip it when you're multiplying or dividing both sides by something negative. In number 2, we're not doing that because we're adding 3 to both sides. Again, leave it open, but we want everything greater than 11, so that's everything that way. Number 3, we are going to obviously divide both sides by 3 to get the x alone. And again, we do not flip the symbol. Now, of course, here it's less than or equal to 12. So it's less than or equal to 12. In number 4, if you multiply both sides by 2, I mean, essentially, maybe I should make it this way. We're multiplying the left side by 2 to get x by itself. So we also are multiplying the right side by 2. So that'll leave x alone. And again, we are not flipping the symbol because it's not the right conditions. And once x is by itself, and so this is greater than or equal to 8. Aha, but number 5. Finally, number 5. Looks like we're going to have to divide both sides by not just 7, negative 7. Both sides by negative 7. So, yep, x is by itself. And we immediately flip from a greater than to a less than, again, for like the 5th time, or more maybe, because we're dividing by a negative 7. And negative 20. And other than that, what's negative 21 divided by negative 7? That's positive 3. So we do the division, but we just got to also make sure we flip to a less than. And so that means it's going to be strictly less than 3, and we're shading to the left, and we're not coloring in the circle. And number 6, looks like we're going to have to since it's x divided by negative 3, looks like to undo that and leave x alone and get rid of the negative 3, we're going to be multiplying both sides by negative 3. So once again, we just do the multiplying, but the greater than flips to a less than. And 10 times negative 3 is, well, negative 30. And so it's an open circle, and it looks like we're shading left. Everything less than negative 30. Again, quick reminder, I like to have my variable on the left. You don't have to, but I think it's easier to read it and wrap your head around like what the graph is going to be. You know, like this one, for example, this literally says x is less than 3. Where's everything less than 3? And it's easy to jump to the graph. Okay, so, starting to get a little more complicated. So first we get rid of the 7, then we'll worry about the negative 2 that's being multiplied to the x. So again, this is not new stuff. The only thing really new at all in this section, and you've probably even seen this before last year or something, but the only thing new in this section, in this class, is that we are flipping the symbol if we're dividing or multiplying both sides by something negative. Other than that, you've done this before. I'm not going to reteach everything. So you should already know that, okay, the first thing we do is subtract 7 from both sides. And what's still on the left is a negative 2x. I didn't get rid of that. This is a positive 7. Like, again, sorry, I can't help myself. I'm reteaching it. But anyway, on the left is still a negative 2x. This remains a greater than, and this is 12. And now, of course, we have to divide both sides by negative 2, which flips this to a less than, and x is less than negative 6. Beautiful. Number 8, of course, we subtract 1 from both sides, which leaves negative 4x over here. We do not flip the symbol. And negative 21 minus 1 is negative 22. Now we find ourselves dividing by a negative, which means this is going to flip, and x will be by itself, and the right side, well, it's going to be positive, right? A negative divided by a negative is positive. Should we, and this, I mean, obviously, I noticed right away, this is not dividing clean. So the classic response to that is like, well, should I leave it as a fraction? Is it going to be a pretty clean decimal? Like, I don't want to be rounding decimals if I don't have to, you know what I mean? That's just a general rule of thumb. You know, for the most part, and it's not like a black and white thing. Math is not black and white like this. I mean, sometimes you round decimals, sometimes you don't, but for the most part, you don't really round decimals. You know, you leave things as fractions, or if something's a clean decimal, that's okay. But, you know, let me see, I don't have a calculator handy. Well, I do and I don't, but I can do this in my head, I think. But it's going to be positive, and it's going to be 5.5, I think. 5 and... let's go with it. If I'm wrong, whatever. Again, we could have left it as a fraction. We could have said it was like 11 halves. But whatever. I'm okay with positive 5.5. And it's greater than or equal to. So we color in the dot. And more of them. What's so different about number 9? Nothing. So it remains a greater than, or equal to, sorry. The left side is now negative 7x. It's a 70, and now we find ourselves dividing by something negative. So this flips to a less than or equal to, and 70 divided by negative 7 is negative 10. So it's less than or equal to negative 10. Now in number 10, okay, something a little bit different, but again, it's nothing new. You've dealt with solving for x a million times, and you should basically know that the first thing you do in general, I'm not saying every time, but if you see a bubble, you probably want to clear the bubble first. That's a pretty good rule of thumb. And how do we clear bubbles? By distributing, technically. And so I'm going to distribute this negative sign, or if you want to think of it as a -1, that's actually technically correct. So we distribute the -1, and it becomes -x minus 2. And of course we keep it less than, and that's all we've done. And then now we can continue like we've done a million times in the past, or you've done a million times in the past. Keep solving for x. Oh, we don't want to get -x by itself. We want to get x by itself. So technically what you can do is think of it as dividing both sides by a -1, because that's technically a -1 here. Oh, and we're dividing by something negative, so that flips. And 7 divided by -1 is -7. And it's going to be strictly greater, so we shade to the right. A couple more. This never ends. But once again, we have to first clear the bubble with the distributive property, and so this becomes a -2x plus, it's the worst plus sign I've ever seen in my life, plus, that's not much better, plus 3. Everything else stays the same. Seems like my pen and board are malfunctioning right now. And we keep on keeping on. We don't flip the symbol. That becomes a -16. Right? -13 minus 3 is -16. At least I believe. And once again, we find ourselves dividing by a negative. So that flips it to a greater than or equal to. And -16 divided by -2, I believe, is +8. Greater than or equal to. Last one, I believe. Once again, we have to first clear the parentheses with the distributive property. So -3 times 2 is -6. -3 times a positive x is -3x. Everything else stays, and of course, just nothing new. And that's going to still be a -3x, and we keep it a greater than or equal to. That's 15. And wow. Again, we find ourselves dividing by something negative, so that makes this flippity flip. Flippity flip. What the heck am I saying? And that's less than now or equal to. Wow, all that just to really say anyway, all those examples just to really make it a point that if you are solving an inequality for x and you find yourselves along the way multiplying both sides of the inequality by something negative or dividing both sides of the inequality by something negative, you must flip the symbol from less than to greater than or greater than or less than, either way.